students, welcome back to your favorite YouTube channel, Tomachang Tutorial. Myself, Kishan Kulum, and today we are going to discuss about remainder theorem, okay? In the chapter called polynomials. We are doing polynomials. We have already completed exercise 7.1 and 7.2. You can find the link below in the description. Please do watch that video and understand the concept of polynomials, okay? Now we will go for remainder theorem. First, let me read out what remainder theorem says and then we will prove this theorem, okay? Let's go. Remainder theorem. If fx is a polynomial of degree n where n is greater than or equal to 1, okay? Fx is a polynomial having degree n. Degree means the highest power of the variable. Fx is a polynomial having degree n where n is greater than or equal to 1. If fx is divided by x minus a, this is another expression. If the polynomial fx is divided by x minus a, where a is any real number, okay? It can be 1, it can be 2, it can be 0, it can be any number, minus 1, minus 2. A is any real number, okay? Then fa will be the remainder. According to the theorem, if fx is divided by x minus a, then fa will be the remainder. This is what we need to prove, okay? If fx is divided by x minus a, then remainder will be fa. This is what we need to prove. Let's go. Let fx be a polynomial of degree n, where n is greater than or equal to 1, and fx is divided by x minus a, where a is any real number, okay? Before proceeding to prove this theorem, let us see how we divide, okay? Suppose we divide the number 7 by number 2. We divide number 7 by number 2. 2 3s are 6. 7 minus 6 is 1. We usually write in this way, isn't it? Where dividend is 7. We know that. Divisor is 2. Quotient is 3, and remainder is 1. Got it? Dividend is 7, divisor is 2, quotient is 3, and remainder is 1. Okay? There is a relation among these four terms: dividend, divisor, quotient, and remainder. Let's see that relation. Dividend equal to quotient into divisor plus remainder. Okay, this is the relation between the four terms. Let's check whether it holds true or not. Okay, quotient. What is quotient? Quotient is 3, isn't it? Quotient is 3 into divisor. What is divisor? Divisor is 2. Divisor plus remainder. What is remainder? Remainder is 1. 3 2s are 6 plus 1. 6 plus 1 is 7. So we got dividend as 7 and dividend is 7. So this relation holds true for every division we do, okay, whether it's algebraic division or whether it is numeric division. This relationship always holds true among these four terms. dividend equals to quotient into divisor plus remainder. So please remember this relation. This is going to be very useful while proving this theorem. Okay, I'm erasing this. Please take the screenshot. Okay, now one more thing I would like to let you know from this is dividend is always greater than the divisor, first thing, and the second thing is remainder is always lesser than the divisor. Okay, divisor is always greater than the remainder and lesser than the dividend. We must keep this in mind. Okay, now let us prove this theorem. Let Qx be quotient and Rx be remainder. Okay, remainder. When the polynomial fx is divided by the expression x minus a, quotient, let the quotient be qx. We are supposing the quotient be qx and the remainder be rx. Let me tell you again. When the polynomial fx is divided by x minus a, we assume the quotient to be qx and the remainder to be rx. Okay, degree, since degree of x minus a is 1 and x minus a is divisor, isn't it? Degree of x minus a is 1. Degree means the highest power of the variable, and the highest power of the variable is 1, x to the power 1, isn't it? So the degree of x minus a is 1, and we know that the degree of the remainder should be always lesser than the degree of the divisor. I told you earlier, the remainder should always be lesser than the divisor, isn't it? Let's do another example, algebraic expression. Okay, suppose we have 7x square plus 5 and we divide by x plus 2. Okay, we divide this expression by this. So x into 7x, we usually divide in this way, isn't it? X into 7x is 7x square. Got my point? So plus into plus is plus, 7x into 2 is 7x into 2 is 14x. Got my point? So this becomes minus and this becomes minus. 7x square cancels. So minus 14x comes in the front, minus 14x, and this plus 5 we write here. Okay, now plus into minus is minus, the same sign should be here. Plus into minus is minus. X into 14. Okay, x into 14 is 14x. Now minus into plus is minus. 14 to the 28, isn't it? Now we change the sign. This minus becomes plus and this minus becomes plus. 14x and 14x, opposite sign. Minus 14x and plus 14x cancels out. Plus 28 and plus 5 is 8 plus 5, 13, that is 33. Now 33 is the remainder here. Means the degree of this remainder is lesser than the degree of this divisor, isn't it? The degree of the divisor is 1 here, and we do not have any variable term here. Means the degree of this divisor is x to the power 0. We can assume this. The degree of the variable is 0 because there is no variable term here. So this is a constant term. Therefore, degree of Rx, that is remainder, degree of Rx should be less than 1, should be less than 1, isn't it? Or degree of Rx should be 0. You can say degree of Rx should be 0. We saw here degree of this 33 is x to the power 0, because we don't have any variable term here, we can put x to the power 0. So degree of the variable is 0, isn't it? So degree of Rx is the remainder. So degree of Rx should be 0. Or you can write Rx equals to 0. This remainder here is 33. Sometimes the remainder may be 0, may come 0, isn't it? Remainder does not always come. Suppose if I divide 6 by 2, 2 3s are 6. Remainder can become 0. Remainder is not always a number 1, 2, 3, 4 like that. Remainder can also become a 0. So either Rx is either the degree of Rx is 0 or Rx is 0. Okay? Either the degree of Rx should be 0 or Rx is 0, which means Rx is constant. Then we can say, therefore we can say Rx is constant, isn't it? Rx is constant. Got my point? Let me erase all these things, okay? Let us assume, let Rx equal to R, okay? Let remainder Rx be supposed as R. Let me erase the upper part to get enough space. Now, since we know the relation, since dividend equal to quotient into divisor plus remainder. We have already proved this relation, we have already seen this relation, and we have already memorized this relation, isn't it? I hope you did so. Dividend equal to quotient into divisor plus remainder. So let us erase this and continue our theorem. Okay. Dividend is what? What is our dividend? Our dividend is fx. Fx was divided by x minus a. So our quotient is qx, isn't it? We have supposed our quotient to be qx, and divisor is x minus a. Quotient into divisor. Quotient into divisor is x minus a. X minus a plus our remainder is, we have supposed remainder Rx is R. Got my point? Let me erase this. Okay. Or let us put x equal to a. Okay? X equal to a. Then what happens? Fa, instead of x we write a. Okay? Fa equal to q into a into x. X is a, isn't it? X is a minus a plus r. Or Fa equal to a minus a is 0. 0 into qa is 0 plus r. Are you getting my point? A minus a is 0. So 0 into qa is 0. So plus r remains here. Let me erase this. Or Fa, that is Fa equal to remainder. We were asked to prove if the polynomial fx is divided by x minus a, then the remainder will be Fa. If the polynomial fx is divided by an expression x minus a, then the remainder will be Fa. We were asked to prove this, and we have proved it that Fa is remainder. So it is proved. I hope you got my point. You understood what I tried to teach you. Okay? Thank you so much for watching this video. I will continue exercise 7.3. Please stay tuned, okay? And don't forget to subscribe the channel and click on the bell icon to get notifications for more video uploads. Thank you.